Right, so we're actually under test with our three-dimensional transformer and found some very interesting things with it already. As you can see, rough as guts, probably not even, didn't count the turns or nothing. One wrap or one layer around each dimension. At the moment we're running on 2.5 volts at 7 milliamps. That is its idle current. That is the waveform we have. Interesting enough, we have a spike in both directions when the transistor switches off, and you can even see, if I widen that time base up, when the transistor switches on, which is here, we get a ring across the secondary as well. During the on time, switches off, dives down, it's about negative 23 volts, and then it shoots back up to 12 volts and then starts its ring during its off time. As you can see, we're running at 30 kilohertz at the moment and 5 volts per division, and our scope is across the secondary, open. So the first thing I noticed that was interesting, even at this low voltage, is that I went to hook up this 12 volt LED, grabbed the body of it, and we now have single wire power transfer. And if I hook the other side up, of course, that is a 12 volt LED. And it has a built-in rectifier, so no wireless until I touch the steel body, and then it comes on. I'll degrease that. So when I touch the steel body, you can notice a small difference. And that is our one wire, and I will be acting as the aerial. Okay, the next interesting thing, this is a 10mm LED, and at 3 volts it takes about 20 milliamps to run. So I have one side in our holder here, so we'll clip our lead to the other side, and then our other output from our transformer to the body, and we have a nice bright, super bright LED. And the good thing is we can actually swap this around like so, if I can get that clip lead to stay on there, and we have a very super bright LED. Now 2.5 volts, this LED will not run, nothing happens until about 2.8 volts. So somehow this transformer provides enough of a kickback in both directions to light our LED either polarity. So super bright, we went up by 1 milliamp, so apparently 1 milliamp at 2.5 volts is what it takes to run that LED like that. Because we draw 7 milliamps, the transformer open, that is its idle current. So very interesting, and I have been fooling around with the frequencies. This thing will still operate very nicely at 1 megahertz, very cleanly. Not like that, around 600 kilohertz we start to get a fairly nice sine wave, and then we go into some jitterish rubbish after that. but at 1 megahertz it still outputs oodles of power to run that LED. So I'm actually going to set up a little light box and test it on here and see if we can get the same sort of light for the amount of power we're putting in out of that LED. So it'd be 2.5 volts at 7 milliamps. We need to get that LED running on that many watts, that bright. So been quite an interesting project indeed. And the thing I like about it is this very forward spike when the transistor switches off. Normally you will only get the inductive kickback, maybe a little ring, but 12.2 volts overshoot from 2.5 volts, very few turns, is pretty good. And we are running at a 10% duty cycle at the moment and 4 volts peak to peak, so we're switching the transistor on with 2 volts, and I'm doing that so as we can keep it below the voltage being supplied, so you know that's not going to be adding any power into the system. So very interesting so far. I might even take the time to make a really good one, but this being able to drive LEDs in both directions, or from either polarity of the output, 2.5 volts at a 1-to-1 turn ratio is quite good. So I'm going to do some light box testing on this now. Now that I have my lux meter, we can get some very accurate input output measurements. Thanks for watching, guys, and I will be back with the light box test on this. So we've got to get that LED to light that bright, whatever watts are at 2.5 volts at 7-8 milliamps. So not very much, I wouldn't have thought. Right, that's it from me for now. Have a good night, and we'll see you next video.